Good day, everyone. Today we have a lot of topics to discuss because we will be tackling about preliminary concepts in calculus. Now, this means that we will be discussing concepts that are very, very essential before we move on to the concepts in calculus. Although these topics were already discussed in high school, but again, to understand easily on the concepts in calculus, we have to discuss this first, okay?
Okay, so we are now on function notation as a continuation of the previous topic that we had. So suppose we have the equation y is equal to 1 minus x squared, describes y as a function of x. So here we have y, which is a function of x. X is what we call the independent variable and y is the dependent variable. Now we recall that the set of inputs or set of x's here is what we call the domain of the function, and y or the set of y's is the range of the function. So suppose we give the name of the function, let's say f. So since this is a function, so by giving the name of the function or by um, giving another notation for the function which is f, so this y here can be replaced by f. So again, we have the input variable, which is x. The output variable or the output value is denoted by f of x, meaning is a function of x. So since y is replaced by f, or it can be replaced by f, so the equation now becomes f of x is equal to 1 minus x squared. Okay? So another example, suppose we have a function y is equal to 3x minus 2. And in function notation, this can be written as like this because another notation for function is g of x. So y can be replaced by g of x, so this becomes g of x is equal to 3x minus 2. Now, not only y and f, we also have h of x or l of x as notations for functions. So how to evaluate a function? Suppose we are given a function like this, f of x is equal to x squared minus 4x plus 3. So this is the same as like this, f of this square is equal to the square squared minus 4 squared plus 3. Now, if we are going to look at this one, this means that x here or these squares here, these are placeholders, meaning we can have any value. Okay, we can have or x could be any real number or any numbers because x and these squares here are placeholders, so we can put any real value on that variable x. So to evaluate f at a number, simply substitute the number for the placeholder. So if you want to know the function value, we're given the function and we want to know the function value given a specific value of x, let's say 1. So all we have to do is to find the value of the function at x is equal to 1. So we just simply substitute it to the variable or to the placeholder. For example, we want to know the value of the function at x is equal to 0. So therefore, um, this is written as f of 0 is equal to substitute 0 to the placeholder 0 squared minus 4 times 0 is plus 3. Then simplify. So this will be 0, then added by 3. So the answer is 3. So this is a function because we have an input value which is 0 and we only have one output which is 3. Another example is if we want to know the value of the function at x is equal to negative 2. So all we have to do is just to simply substitute negative 2 to the variable. So f of negative 2 is equal to quantity times negative 2 squared minus 4 times negative 2 plus 3. Simplify, we have 4 plus 8, which is 12, plus 3 is equal to 15. So we have the input value, which is negative 2, and the output value is 15. So meaning if you input negative 2, then you um, you expect that the output is 15 based on the given function. Next is, if you want to know the value of the function at x is equal to h, so we simply substitute h to the variable. So this becomes f of h is equal to h squared minus 4h plus 3. How about if we want to know the function at u plus v? Okay, where u and v could be any real number. So we just simply substitute u plus v because we want to know the function value, right? At x is equal to u plus v. So all we have to do, this u plus v will be will be substituted to the variable x. So this becomes quantity u plus v squared because this is x minus 4 times quantity u plus v plus 3. Then simplifying the whole equation, we have u squared plus 2uv plus v squared. Then simplify minus 4u minus 4v plus 3. Then combine like terms. But in this case, um, there are no variables with the same, or there are no terms with this with the same variable. So this is the final answer. So this is our f of u plus v. Okay. So another example of a type of function, which is a piecewise defined function. So here we are going to find also or to evaluate this type of function, and we are going to discuss first how to find the or how to evaluate this type of function. So what is a piecewise defined function first? A function defined by two or more equations over a specified domain. So this is what we call a piecewise defined function if it consists of two or more equations over a specified domain. For example, we are asked to find or we are asked to evaluate the given function. Now this is the given function. So evaluate the function when p is equal to 2 and 3 over 2. What type of function is this? This is what we call the piecewise defined function because by definition, it consists of two or more equations over specified domain. For example, g of t is equal to t squared if t is less than 2. So t squared if the domain is t less than 2. But 1 over t if t is greater than or equal to 2. So they have or it has a condition, right? So and it has also two or more equations. In this case, we only have um, two expressions over specified domain. Now, how can we evaluate this one? We can evaluate this one by satisfying the domain of the given function. Okay, for example, because, so we are asked to find g of 2, right? Because we are asked to evaluate the function if t is equal to 2 and 3 over 2. So all we have to do is to substitute our our t. But we have to take note of the domain. Now, because t is equal to 2 and the condition t is greater than or equal to 2, so all we have to do is to substitute our t is equal to 2 to the corresponding expression. Okay? So since the corresponding expression is 1 over t, okay, based on the given function t because it falls to this case that t is greater than equal to 2. So we just simply substitute 2 to this expression. So g of t in this case is equal to 1 over t. Okay, to obtain that one, we have g of 2 is equal to 1 half. Now, how about g of 3 over 2? Now, 3 over 2, you have to remember that 3 over 2 is equal to what? 1 and 1 half or 1.5. Now take note 1.5 is less than 2, right? So, you choose the right domain since 3 over 2 is less than 2. So it falls here. So if t is less than 2, you should use this expression. Okay, so this is now your g of t if this domain is satisfied. So since you are asked to find the g of 3 over 2, so we just simply substitute 3 over 2 to the given expression. So this is g of t squared is equal to t squared. And to obtain that one, we have to substitute g of 3 over 2 to the first expression. This is equal to quantity 3 over 2 squared, which is equal to 9 over 4. Okay? So this is how we evaluate the given function. So hope you like this video, and for the next topic, we will be talking about the domain of the given function. So thank you so much, and don't forget to share the learning that you got from this video. Thank you once again, and God bless.